Hey Donna.
Hey, how's it going?
Yeah, good. Yeah. I'm in China right now.
Oh, that's nice.
Yeah. I arrived last Saturday night and then it took a long way to go to the Beijing.
Mm-hmm.
Let's wait for a couple of minutes, then we can start. I think we already started. So last time, like Michael found the Cisco talked about the BG picks. So this time we want to like give a proposal to see how we want to handling the BG picks. So then I would appreciate of everybody's opinion to see that how we can fine tune this solution. And any suggestion will be welcome. So then hopefully this will be a good community collaboration project so we can bring the BG picks to improve the conversions. Can you sharing the slide? So then we can start about. So before we start on that,
Okay.
any like comment? Can you share a slide? Okay. So, so this is basically initial proposal, which I and a couple other folks from the action also like to we look through the code and also we're looking look through the presentation which Mike provided and we want to give a proposal to see how we want to handle it. And this is basically say we want to this is our initial goal and for this topic we are focusing on most of the items for the conversions. So that's a problem we are but for the real problem, let's go to next. So we talked about it like this is the yeah, go to next. Yes. This is the first issue last we talked about a couple of weeks ago. The Shrine from the Alibaba will talk about this is basically say the underlay routes flapping, which is affecting the overlay SRv6 routes. So today and once we have the underlay routes and the flapping, the overlay routes keeping moving around. So I don't need to repeat the whole details, but this is the great example to show, like say, if we have the BG picks, this definitely will help into solving the problem. So this is the one issue we have in mind. So then go next. Then the other issue is last time we see is from the Alibaba case is basically the recursive route support. As of today, we don't have a good recursive route support, so we need to flapping the routes once we either go into the kernel or go into the FPM. So these recursive routes which once we clapping them, that will be introducing the huge number of the paths. So that's where we see that over 256 passes. So this is the issue we saw in last time. And right now the fixing, we just removing the duplicate the paths. So that more like the bandage, fixing the problem, but the convergence will be in the sucks. So that's the one. Then the third one is the last time like Microsoft can go next. Yeah, so this is the last time, like say Microsoft the T2 chassis issue. So we see the crashing, and we debugged. Hassan was do the live debugging here. So in that case, basically during the transition period, although initial design, they don't need to have recursive routes, but during the transition period, they forming the two-level ECMP, which also leads over 256 paths. So for this particular case, also the solving is basically removing the duplicate the paths and to solve these particular issues. So these are the three issues which we discussed in this working group. So this is more like the motivation for introducing the picks. So for the design, this is more like for the high level what problem we want to solving. So the first thing is like we want to enable the pick via the zebra bring up argument. So we don't want to do any like say on fly to enable disable because that will be way too much. So this, we want to, like I say, just bring up the zebra, and the zebra will be enabled by default. Will be, if you don't enable it, it will be always, like I say, as current behavior, but we allow the bring up to another mode to enable the BGP picks. Then SONiC can using the config to managing during the bring up time. So based on config, we can have a different, like I say, bring up argument for the zebra. So then the second one is basically we were focusing on the SRv6 VPN, MPLS VPN at this moment to solving the first, because the reason I bring in the MPLS VPN because from architecture design point of view, they are very similar. So I was thinking that for solving the first one, recursive routes, we probably can come back later on. So this is not covered in this slide proposal. So that I just set up the recap this issue and basically just set the tune to see what is the problem we want to solve at this moment. Any comments?
Yeah, I have a few comments, Eddie. So when it comes to BGP and Zebra, I think you're talking about a very different issue here, that BGP, even though it is not doing the recursive next hop resolution, it is actually flapping the routes whenever the underlay next hop changes, right? I think that is the primary issue here.
Yes.
So
yes, I'm using the VPN because that's a problem. But if you go to the slide, the issue 1, how you can go back to issue 1? Yeah. So this is basically the initial, like I say, why we need it. So BGP solve this problem and also solve another problem is that, like I say, if the BGP next hop down, then we also get a fast convergence. So there are two problems we want to solve. But the other one is more like a benefit, but this one is more like the testing we observed issues. Yes.
Correct. So I'm giving a different perspective here. Actually, what you're saying is, makes sense. But what I'm trying to say here is maybe the two-level next hops are not the right usage, or maybe an overkill for the problem that we're trying to solve here. The reason is, if the prefixes are pointing to a next hop, does not matter whether those are recursive next hops or collapsed next hops. The next hops are not going to be huge. They may be within right. So and if we have the flexibility to update the next hop without touching the prefix, we are actually getting the benefit of, or rather we are using the pick in a sense.
That's true. That's a valid point. So that's but if you get to the for SRv6 today, we are kind of okay because we are most time we're using the proverb. It's more like a proverb label. We use a verb sit, and for the MPLS there are 3 variations: per prefix, per verb, and per CE. So if you go in with the per CE label, per prefix label, then your number of the prefixes actually is huge. So that's the another motivation. Yeah. But
I think, right, Eddie, it might be easier to talk about this first in the context of pure IP, and then bring the MPLS and SRv6 aspects into it, right? Because there's a problem statement that needs to be solved even at a pure IP level. where you have millions of IP prefixes that are advertised by a handful of underlay next hops or underlay neighbors, your IGP neighbors, if you will. And we want to make sure that when that IGP membership changes, you're not pushing or you're not updating those millions of routes again. That's the fundamental thing, right? So it might be easier to talk about this in the context of plain IP first, and then bring in the MPLS or SRv6 use cases.
That's a good point. That's can you go back to the like the summary page? Like, yeah, I think that's the other one, probably the slide 5 or 6. Basically after the slide in the issues. Basically, right now we didn't because issue 2 and issue 3 are the global table, which is the plain IP. But at this moment, I don't know, like I say, how many routes we see here. So because in our case, the global table itself, we probably around the 500K routes. So it's big, but it's not that significant benefit. But the other one, that's why I was attacking the SRv6 first, because I need that one to be solved first. But I agree with you, but that's why I'll put it like say the issue 2 and issue 3 will come with the next proposal.
Okay, no, that's fair. I mean, if the immediate problem is SRv6 or MPLS, that's fair. Or the reason I was mentioning is if we solve the problem for IP, then the rest of it should be an extension of that. It might be easier to talk about in the context of the simpler problem first, but it's fine if you want to talk about SRv6 or MPLS first and then generalize to IP. That's okay too.
The reason
I would say, it's a valid point. I mean, Praveen, you brought a good point here that we may have to find out whether IP is having this problem first of all or not, right? And then we can say that.
Correct. Yeah, because that's the most simplest problem that we need to solve, right? Everything else is an add-on to it.
Yeah. So what is your thought, Eddie, on the pure IP? So let's say a BGP prefix is being recursively resolved using an OSPF prefix or OSPF next hop, right? So do we need, what do we need actually in terms of the...
If for me, for example, for this case, then I would prefer, like I say, because Zebra today, we have the recursive, like I say, chain built up already in the next hop. And so we could leverage that, and we want to pass down the next hop group for the non-recursive level and also recursive level. So, but here there are two options. One is, like I say, we were just honoring that, hey, we were pushing the IGP next hop group first, then we pushing the BGP next hop group. Then this one, it's basically, it's not a big change, but that one will require a SI update, because as of today, SI doesn't have this recursive next hop support. Then the other option is like we just pushing the combined, so we solving the problem halfly. So we just clapping them and pushing the next hop group directly. And then each time we have the IGP path changing, we need to trigger the backwalk and update all the corresponding, like say, next hop groups. So that one, that's why I would say I want to probably discuss it later on, is because there's two variations. So I want to see from the community point of view, which one will be easier to handle. But my personal opinion, I will go with the first one. That's pretty natural. I can have I try to avoid in the backwalk, basically.
And the first one is the MPLS VPN or the SRv6, Eddie? Which one?
I would say because the SRv6, from architecture-wise, both are the same. So I would say that from design point of view, we would, but from the implementation point of view, I would take SRv6 VPN first, because all the SI code, the Cisco Silicon One already supported. So that's why also the natively, because this is a tunnel like NH, so it's kind of natively have a recursive support. So I don't need to, like I say, extend the SI APIs. So that's why I picked the SRv6.
My only concern was that if we solve the specific case first, then we might actually end up having different solutions for for the tunnel case and for the non-tunnel case. But it's okay. I didn't want me to kind of rat hole on this. We can walk through the proposal and come back if need be.
That's true. Yeah. So that's how I would say, like, let's look at it once, because this is more like the first time we introducing this the next hop group and also the label array, this concept. So I want to, that's why I on purpose that I say from a protocol point of view, we want to see both the MPLS VPN and the SRv6. So at least from the design, we need to make sure that this proposal need to be fit for both.
Okay. So you may want to actually explain a little bit what is going on in the slide for everybody's benefit.
Okay, so what we want to, like I say, the main benefit is, remember last like say 2 weeks ago, like say Mike explaining like how the BGP picks the draft will be. This is the more like the implementation draft. And the main goal is like say we want to solving solving two problems. One is like underlay IGP path changing should not affecting the overlay like BGP changes. So that's where we get the fast convergence. The second one is even more important is like say if the next hop BGP next hop going down, we should have the convergence independent of the prefixes. So basically, we could allow the BGP next hop to be updated first, then update the VPN context accordingly. So that's the initial, like say, the tone like set up by the Michael to say how we can what the BGP picks will be. So that's two enhancement will be included in BGP pick. The other more like the variation on these two enhancement. Then we will basically say looking onto that's more like a design guideline. Then looking onto the existing code base and see how we can implement this tool into the two use cases, which I would say SRv6 VPN and the MPLS VPN. The global table is more like a special cases. So in that from that angle, because
so in this case, Eddie, on this slide, is the prefix ABCD the MPLS prefix, and then the first level of
this is the global table. This is
okay.
This is in the data center, so everything is just a recursive, very basic recursive routes.
Sure.
Yeah, this one is basically what you mentioned. Like say, hey, if we have a proper recursive route support, we would be able to solving this problem. But for me, I would say the basic recursive route support is more like say a special case for the BGP picks, because it's more like say I don't need the VPN context, but the logic will be the same.
Okay. Do you have the picture for the VPN use case? Just kind of visually see the problem statement.
VPN use case, I did. Can you go back? Can you go back to the slide one? No, so issue one. Sorry. Yeah. So this is more like say the currently we dumping. So if you see that this is on the VPN side, we will have the VPN routes which go into the two paths, which is the BGP next hop, and this BGP next hop, this is will be say. So it's if you see this one, so this is the FD. So if you see that this is the V4 VPN routes 114.2/30, then this is by the V6 segment, which is the FD 00 something that. So then which will be resolved through the underlay routes, because this is the BGP next hop, which is through the underlay routes with FD 00 to 200 something, which are by the A and B. So if you're looking down, and so then you have the A, B, C, D something at the prefix, which will be the prefix going by more like IGP routes. So this is the basically say the show as a show IP route to the currently the VPN chain.
Okay, got it. So basically, your service route is the 114 route. BGP next hop is the FD00, and then it has two IGP next hops A and B. That's the chain,
Yes.
right?
Yes, exactly.
Okay. And today, whenever any of these changes, whether the underlay next hop, underlay resolution changes from, like as you said, the FD00 instead of being advertised by A and B now changes to A, or there might also be, are you also considering the case where the 114 itself is resolved via two different BGP next hops, or that comes later?
Yes, I will resolve. Basically, it's the 114 that will be resolved by two BGP next hops.
Right,
Here
right.
I'm only showing the one, but you can consider this is a one pass BGP next hop group.
Sure. Yeah. So in this case, what you're saying, just to understand this slide, that anytime that underlay next hop changes, BGP is going to push the resolution is done in FRR today and pushes that to Zebra, like if there's 114.2.00 is directly resolved over A and B versus A, and that changes today. Is that what the first two sub bullets are showing, or?
Today, the reason is we don't have basically today we don't have the next hop group change event. So into the FPM. So any of these update will need to inform the BGP. Then BGP will be flushing all the routes, the BGP routes again, even there's no update in the BGP route, because BGP doesn't know that he doesn't have the update in the BGP routes. So he always update it.
Yep, got it. Yeah, and then that kind of flows from Zebra into SONiC.
Yep, and also today, right, because we need rely on the leaf to bring the next hop group update.
So suppose this FD00 prefix next hop changes from two path to one path, right? And in the BGP table, if you see, we will just see 114.2 with having the next hop as FD00.
Yes.
Right. Now, the question here is, if the next hop resolution or basically the prefix next hop for FD00 is changing, does BGP even need to know about it? I would say BGP just need to know whether the FD00 next hop is reachable or not reachable.
Today, BGP knowing it is because BGP we learned it also through eBGP. So the FD00 routes update it's through the eBGP. So once the path changing, IGP path changing, this event going to the eBGP.
Yeah, but BGP is not the one which is calculating the final recursive next hop, right? It is.
No, it doesn't. But since it's going to eBGP, then it will be also go through all his routing table, right? So he will flushing the routes. And right now we rely on this to flushing, right?
Eddie, isn't this like a two-level problem, really? The first level is that BGP has to be able to reinstall the route changes from the default VRF. And it also has to then resolve everything through BGP. The BGP then has to be able to handle the changes in the VRFs. And part of the problem is that there's a lot of BGP work that needs to be done, and both the default VRF and the non-default VRFs are running at the same time. And so that's one part of the problem that I heard. And I remember that's from one of the discussions we had earlier. And the second part of the problem is that we have to re-resolve all the routes as they're reinstalled. And so I think it really kind of sounds like there's two problems that need to be solved. One is that we should probably make BGP always do the VRF default first if there's work there before it does anything else.
So, so I would say, Donald, I think, Zebra is the one which is actually solving the problem number one. BGP is not, aware of any next hop recursive resolutions.
No, but BGP is getting path infos changes from its peers and installing those into Zebra.
I agree. But in this
And so
example,
I said there's two problems. I said there's two parts of the problem. There's one is that BGP is tripping over itself, right? Where it's installing routes from the default on the non-default VRFs, and then along comes a default VRF change, which causes a whole series of rework. And all I'm suggesting is one part to make things more sane or saner or quicker is handle the default VRF first, and then you'll get a little less churn. It won't, but I think you do both.
Yeah. Because in our case, basically it's a flapping. So then we eventually, like I say, through this flapping, quick flapping, eventually like throwing the Zebra to make the wrong decision because we have so many routes up front. So ideally, this IGP convergence should not impact the BGP. So ideally, say that the BGP should not reinstall the routes.
Correct. So I think that is the problem, right? That when the underlay next hop changes, why BGP in the overlay and the VRF is actually reinstalling the routes, because the next hop is still reachable, even though the number of paths for that next hop has changed from 2 to 3 or 3 to 1.
Agree. Yeah.
But there is absolutely no reason for BGP to reinstall the route if the next hop reachability is not changing.
Mm-hmm.
Yeah, I think that's the first problem. The BGP problem would come into place when you have the same service prefix advertised by two different BGP next hops, and when one of that changes, only then BGP
Correct.
will need to really like reinstall any of these, right? Otherwise,
Correct. You can simplify and say that this is like overlay next hops changing, not the underlay next hop.
Yes, exactly. Yeah.
Yeah.
Okay.
So this is quite basic question, but so this is also a Zebra FRR problem, and not only with SONiC, right?
Yeah. So this is we talking about more like from the Zebra point of view. So so my proposal is basically say let's start to looking at the Zebra. So adding what are the bells and whistles we have, then we can enhance more like ongoing basically, like say should we suppress the message from the BGP or those things. So that it's like two separate problems. Yeah.
So, I think we should look at both of them in parallel, right? Because ideally, this problem statement is something that needs to be discussed in the FRR community. And what we need to do, I'm not saying we shouldn't discuss it, but at the same, in parallel, we need to also focus on what constructs do we need in SONiC and SAI to be able to build a recursive chain pick-enabled recursive chain in SONiC and in SAI, so that once Zebra and FRR do the right things, SONiC has the right structures to be programmed by FPM-SYNC-T.
Yeah. And that's why I would say let's look at say how the Zebra change would be. So what I would take is like say pick from the last time the Mike's comments is like say in Cisco, this one will be done in the RIB. So I will start first just to attack this problem from the RIB point of view. So say, hey, if we change the Zebra, what the change will be to we can make the problem getting better, but may not be like it's fully the solution, because we eventually still need to solving the same problem in the BGP. But at least I want to using that as an opportunity to build up the infrastructure to say, hey, I will passing down the next hop group and the label array down to the FPM. So then we could start to building the next hop group and the label array independently. Yeah. Okay. So So this is more like the problem statement point of view. Okay.
So AD,
Okay.
from the recursive resolution perspective, right? Yeah, from Sai, I don't know if you want to program the backup path and all those things, we might need some changes, but to program the recursive route itself, right? Do you expect any change? I don't know. I mean, do we need to indicate as part of the next hub installation that this next hub is not directly reachable? Rather, you need to do one more lookup to get the actual next level next hub or something like that. Do we need to do that? I believe the underlying NPU can do that second level lookup if the next hub is not directly reachable or something. Is that correct or no?
Normally, like that's depend on NPU. So this is a
Right.
site design. So if, like I say, I try to avoid another lookups, because then it's more like a tunnel situations. Even like for the tunnel situation, normally people will basically say in the SI or SDK, they build up they do the lookup in software and build up dependencies in hardware. So hardware is always the chain walk. Then in this case, this is side we can discuss it further. Like say, once we give the members, how do we give the hint to say, hey, this member is recursive? You need to resolving through the existing next hop group, or you say, hey, I will give you the next hop group ID directly, so you can build up the dependencies. So that's something we probably need to discuss, because as of today, the side API always be one level. We never talk about the 2 levels, except the tunnel case.
Right.
So that's why I delayed the on purpose. I would say I will start with the global table later on, because global table we would require the side changes.
No, but even for the Eddie, even for the VPN use case, we would need the constructs to represent the recursive next hop group and the underlay next hop group, right? Like, let's say, for example, I'm just kind of generalizing this to the next level, where your service route is learned through 2 BGP next hops, right? Yes, it is a VPN route, which means you're going to do the route lookup in the context of a VRF, and you'll get the labels associated with the next hop. But it's still a special case of the fact that you have a service route that is reachable over a next hop group of 2 members. And each of that next hop group members is now pointing to either the same set of, another next hop. It could be one next hop group or 2 different next hop groups, depending upon how your BGP next hops are resolved. So at the end of the day, SAI would still need to have a construct of a prefix pointing to a next hop group, pointing to a next hop group, pointing to a next hop. Right? That construct, whether it is VPN or not, you would need that construct.
That's a good point. Actually, right now we because I think recently, like the Silicon One team already pushed the side changes for the SRv6. So the first level, the BGP, they also introducing another, like the next type with SRv6. So the member wants the SRv6, then that already give the hint to the SDK to say, hey, this is a tunnel case, basically. So they would know that they would start with a recursive lookup there. So that's why I would say.
So I'll actually register a concern there, Eddie, which is, I generally don't think that it is a good idea to solve the specific problem first and then solve the generic problem. Because what happens is, if we may be solving the problem for SRv6, recursive route resolution, right? But there is no guarantee, unless we examine it properly, that the same structure can be replicated for solving an MPLS use case or a plain IP use case or a VXLAN use case. Because they are, at the end of the day, you would really want to have a common solution for no matter what the tunneling technology is and no matter what the segmentation technology is. You would want to have a common solution for how recursive route resolution gets done, whether it is over tunnels or whether it is over plain IP or MPLS next hops. So
that's a fair point. That's I fully agree.
That is my concern, that if we solve it for a specific use case, we may be losing the bigger picture, and then we'll have to have individual solutions for each of these.
I would take, like I say, because I have one specific use cases, and I try to, like I say, avoiding the boil the ocean. So in the kind of, like I say, things I can reusing the existing bells whistles. So get some, like the ground back lay on directly, then we can adding on top. But that's why I say this is just an initial proposal. So I'm not saying this is the must have this way or that way. It just say like we can understand the problem, then we see then how we tune it to make it generic. Because in this group, a lot of people already done the MPLS support, or like I say before. So, or like I say the global table before. So once we lay down the unfolding chain, then we can tune into say, hey, this is a place we can put more information so to make it more generic. Also say that's why I want to go, because in general, from my point of view, SRV's VPN, MPLS VPN are very similar. Global table is also kind of similar case. So that's why I would say I start some a specific use case to bring the easy to discuss. Say I have a very specific use case, but the phone chain could be generic. Then we will say,
that is fine. Right? The use case, looking at the specific use case is fine. When we go to the solution, maybe I'll hold off my concerns till we look at the solution. I might be, yeah.
Okay. Good. Okay, so Henry, you want to continue from yours part? So I already described the problem and what is our goal. So let's look at the proposal.
Okay, let's continue. Okay, this is a basic SRv6 VPN network consisting of P1, P3, and P4. And each P has two wharfs, public and private. And each wharf has several routes. P3 and P4 will send these routes to P1 as BGP VPN routes. So we can see the format of the routing table on P1 like this. Based on the current implementation of Zebra, the format on the left is how the routes on P1 are stored. We can see that the route 1.1.1.1 in both public and private use the same next hop with ID1. Similarly, the route 2 uses the next hop group with ID2. The difference between next hop group 1 and the next hop group 2 is that each next hop corresponds to a different VPN seed. On the right side is the desired state that we want to modify in this design. We can see that we extract the seed list information from the original next hop group and store it separately in the pick context list table. The next hop group now only stores the next hop IP address. Then we add a context ID field in the existing routing table to indicate the corresponding context member for each route. After this division, the meaning of the next hop group table is to specify the outgoing direction for the traffic. The pick context list table now represents the encapsulation of the outgoing packets with seeds. For example, if a flow matches the route 1.1.1.1 in the public wharf, based on the NCG ID1, it will then determine that this flow should be sent to the next hop 2000 and 3000 by ECMP. Then based on the context ID 1000, it will find the pick context entry with this ID. According to this entry, it will encapsulate the packets sent to next hop 2000 with FD00 as the SRS, and will encapsulate the packets sent to the next hop 3000 with FD00 3000 as the SRH. So this page demonstrates a BGP peer down use case. when the link between P1 and
Sorry,
P...
can we go back to the previous one just to kind of spend a little bit more time? So basically, to summarize what you're saying, currently, every prefix that is advertised by a set of BGP next hops, Zebra creates a unique set of next hop group table, right? Or next hop group table entry, whether even if the actual next hops are the same, which in this case for the public 1111 and private 1111 and 2222 and same thing on private side. Today, Zebra creates different next hop groups with different SID lists. And what you're showing in the middle is that after the BGP PIC design, Zebra would be modified to start sharing the next hop group tables wherever possible. So if two prefixes have the same next hop group, then Zebra would create a single next hop group and it will keep some sort of a ref count. And now it is reusing the same next hop group for all the service prefixes across different VRFs. Is that an accurate representation? I'm just trying to kind of read this slide and make sure that I understand what it is. What's the change?
Yes, correctly.
Okay, and the far right side here is showing that for that next hop group, it is showing the two next hops within that the actual next hop list. Okay, all right.
Okay.
I think what might be good here for our later update, not now, is to actually carry forward this table to show. This is showing up until the Zebra construct, right? And what happens in AppDB. I think what would be good is to actually show what happens all the way into SAI. Like if you extend this one more, what is the current construct in AppDB, and what would be the current construct in SAI, and what would be the new context in SAI? It'll be good to show that as well.
Sure, we can add it. For this particular case, because we are talking about SRv6, we are mapping to the existing SAI, the APIs.
Yeah, that's fine, Eddie. Just for completion's sake, right? It'll be good to kind of show that. Yeah.
That's the point. Yeah.
So SID list goes into the next hop in the hardware, right? Or you can say side.
The list today, so we probably later on, it will not be in the next hop group. It will be in a separate data structure. So because if you want to do the PICs, the hardware itself need to have a way to separate the PICs context from the next hop group. So in general, logically, you can consider you have the two separate hardware structure, one for the next hop group, which is shared by everybody, and the PIC context was shared based on the how the PIC context information will be. If it's the per prefix, then it will be the prefix. Each of the prefixes will have its own context. So that will give us the fast convergence, because if you have the BG path away, we can update the next hop group directly to bind the time. That's where he coming for the next slide.
Basically, a pointer to the SID list table from the next hop group.
Something like I would say more like you can consider the PID list is more like the leaf attribute. So that's why you see that logically you can consider there are two pointers from each leaf in hardware. One pointing to the next hop group, one pointing to the PIC context. But then in the hardware, how it's really handled, it's really dependent on hardware. We can later on to show, like you say, how the current SRv6 side will look like.
Yeah, but currently the SAI APIs are like when you're creating the next hop group, you have to provide the SID list as well.
No, we don't. So this is the BGP, so it will be in the APIs. They have separate API for that.
Okay.
That's why I would say I pick something which is easy to solve, because the SAI API already be PICs ready for the SRv6.
Okay.
So one question: why we have next hop list both in the next group table and pick context table?
Sorry, say it again.
Why we have next hop list both in pick context and next hop group table?
What's the context between the?
Yeah. So
Then
for
the
next hop
context.
group, yeah.
Okay. So the context ID. So basically the context ID could be used as a key. This context ID in the SRv6 we call the aggregate prefix ID. Basically, it's basically some derived based on your next hop and also the prefix. So logically, you consider this is like control plane assigned ID associated with this leaf. Then this leaf, we're using this ID, the 1000 in hardware to figure out what is corresponding, like say the SID, VPN SID will be if I'm pick up the 2000 BGP path. If so, he basically using this ID and the BGP next hop, these two information to find out the VPN SID.
So, but there is next hop list in the pick context list table, and we also have next hop list in the next hop group table. So why we have next hop list field in the both tables?
Oh, the first one is just regular, like I say, the next hop group. So you basically say, hey, this is so logically it's just the regular ECMP. The second one, next hop group, this ID is really dependent on how the PIX context list be implemented in the hardware. So it's really dependent on, like I say, in the currently Silicon One case, they were organizing the VPN SID based on the VPN next hop. So the 2000, then he organizing a table for all the VPN SID belong to the 2000. And then the index based on the context list. So the context ID is unique within the VPN context. Because that's come from, that's why it's called aggregate the prefix ID. It's related to your prefix. Then in some of the hardware, which I worked before, which we created as array in hardware. And in that case, the list basically give me the index. Say, hey, what's the index within the ECMP list? And then I was using that index to figure out what's the corresponding in the VPN SID. So it's really dependent on hardware.
So, are there any case where pick context 1000 and 1001 has different next hop list?
You could, right? So say, for example, if as long as right now we are sharing, right? You see that today in this example, 1000 and 1001, they are sharing the same like next hop group. That's why they have the same next hop group list in there. But in the reality, for example, hypothetically, if they don't share, then you have the different next hop group list. Yeah,
I see. Thank you.
Okay, continue.
Okay. Okay. This page demonstrates a BPP down use case. When the link between P1 and P3 goes to down, we can observe the fast rehashing functionality implemented by the table entries based on the BGP peak design. Before modification, the dependence of traffic convergence on P1 is all green and red routes need to be withdrawn. But after this design, we can see the table entry update action for control plane flushing after BGP next hop going down. When the next hop 2000 column 1 goes down, Zebra will quickly withdraw the route for this route and locate all the next hop group that include this next hop and remove the next hop member from those groups. After that, there is no need to wait for route updates, and the traffic can be quickly switched entirely to the next hop 3000 column 1. On event 2, BP peer 2000 column 1 will go to down, and BP will withdraw the routes from Zebra. Then the routes will gradually switch to the new next hop group, which only has one member, 3000 column 1. And the pick context list table will also be refreshed and removing all the members corresponding to 2000 column 1. This is the current data structure design for routes in Zebra. It can be seen that the current HSRV6 label and Winnie are stored in the next hop structure. We need to extract these fields and place it in the pick context table. The modified data structure design is shown in the diagram. We extract SRV6 NH label and Winnie from the next hop and store them separately in the Zebra pick context table. And only the IP address is retained in the next hop structure. This way, we can make sure that when there is a next hop update, we can trigger the update of a next hop group to quickly refresh the table entries in the data plan. Then this achieves the goal of fast convergence. So the changes in Zebra is Zebra stores and receive the routes and add them to the process route queue. Will reap add a multipath NG function. During this process, Zebra needs to select the next hop information carried in the route message into two paths. The first is a group of next hop information, and the second is pick context list for the corresponding next hop group. Zebra maintains pick context list in pick context list table. Zebra performs route selection started from RIP process and prepares various forwarding objects to the data plan. And two new type of forwarding structures would be sent to FPM SINC-D. When a next hop in a next hop group is unreachable, it triggers a change in Zebra's next hop group table and removes the down member from all next hop groups it belongs to, and refreshing the next hop group table to FPM SINC-D. The changes in FPM is we need to add two new type of messages handling in FPM for next hop group and pick context list. A next hop group could use net link message format and pick context list uses protocol buffer format. We need to use one socket to handle both protocol buffer and netlink message type for FPM. The changes in awk agent is the awk agent would use configuration to where it is in BP pick support mode. In BP pick support mode, the awk agent would read the events from next hop group table and pick context table and handle these forwarding objects accordingly. So that's all information about the BP pick. Thank you.
Hey, can we go back to the slide where you were talking about the next hop group list and the pick context table? I think it was 2 slides. Yeah, the one next
This
one. No, the one after. No, where you were describing the changes to Zebra. There's a text slide.
This one.
No, one more. The text slide.
Yeah, the text. Yeah, this one.
Yeah. So what is the what's the purpose of actually splitting this into next hop group information and the corresponding pick context list? at this stage? I mean, I understand that for a particular hardware implementation, we may have to do that. But at a control plane level, is it because it's not, let me not guess. So what is the reason to actually split this into two separate tables?
Because we want to, like I say, this is the BGP group, a group of the next hop is basically the BGP group, right? So if the BGP goes down, you want to be able to update that first before updating all the VPN context. So
the VPN context is on a per route basis?
Could be on the per route basis, right?
Oh, okay. So these are not related in the sense the next hop group information in the PIC context list is not one for one.
It's not one for one, yes. So that's why the picture, like I say, they're all sharing the same next hop group, but the VPN context really depend on the prefix.
Your allocation model, how you allocate the seats and labels. Okay, got it. Yeah.
Good. And sorry, one question. I guess it was a couple slides before you got to the diagrams. What was the example of error handling or neighbor going down? Were you updating the existing next hop group, or you create a new one and move the prefixes to that? This route, so that's next hop going down. Okay, so that's a quick update, right? You can remove the bad neighbor. What was the next one? Event 2?
Then I changed it to be 3. So because normally it will be updating to the new. Basically, we updated the BGP prefix one by one, right? So you basically unbind from the old one and create a new one to bind into. So that's why on purpose I use ID 3.
I see. Okay. Yeah, that wasn't clear. Okay. Yeah.
So these next hop groups and the PIC context will be created in BGP or in Zebra?
Right now, I want to, if you go to that his slide, we only want to change in the Zebra. So you see that we didn't change anything in the BGP. So that's get the hint from last time that Michael said that Cisco only do on the RIB, right?
Right. So so when the neighbor is going down, I think you had a slide, right? For the neighbor going down. That you may not be able to optimize.
You mean neighbor? You mean like the BGP neighbor, or you mean like IGP neighbor?
I think this was BGP neighbor, right? Maybe you can flash the slide.
Yeah, that's why like in BGP neighbor going down, there are 2 events. Event 1 is basically the say IGP convergence. So you know that your BGP neighbor is unreachable. So you can go back to the slide 1, the event 1. Yeah, so you see that here we were basically just removing the failed link directly in the BGP next hop, because that's you get through your IGP event. So then we update it. Then it's followed by the Michael's question is like say, then the BGP will get informed, hey, because now all the routes will need to be withdrawn. Then route withdrawal will be going one by one. So we definitely were not reusing the next hop. We're moving unbind.
Right. So that later will happen when BGP reacts.
Yeah. But the same, and since like I say, the next hop is already fixed, so your traffic loss will be fixed at this moment at the event 1. Your like a control plan structure cleanup and data plan cleanup will be on event 2, but there's no traffic impact.
Correct. Right. I think this is what we were also talking in the previous meetings, that the reaction should be closer to the hardware.
Yeah.
Yeah.
So that's what basically where the BGP picks, because the BGP picks there are 2 parts. One is the IGP convergence handling, one is the BGP convergence. This is for BGP convergence handling.
Okay. So I think associated to this, you will be proposing some side changes as well.
This one, that's why I would say like for the SRv6, I don't propose any in the side changes. Maybe next meeting we can go over the existing side APIs for the, so we can map in the current object to say mapping to the existing APIs. So
yeah, I mean, I was looking at it in the background. So actually, next hop, it can have the SRv6 SID list as an attribute. I think this is what you mean by context here.
Yeah. So the context itself have its own data APIs which we can map into. So my point is, like I say, today the code on the SONiC API, like say Silicon One provided, already had the big PIX enabled support.
Sure.
Yeah. But then this then that will bring the next question in the global table. The global table, then I do need the side changes. That's what probably I want to discuss it maybe later on.
Sure.
And Eddie, I guess this pick context list table, this is optional, right? We were talking about if you could have a generic solution for pure IP. Can the context ID be 0 for pure IP case? Okay.
Yeah, I would say like we probably reserve 0 and say, hey, I don't using the ID.
Sure.
Yeah, global. That's why I would say that for the global table, basically, I don't need this context because this is really the VPN context. Good. Any further question?
I think it'll be good to review the SAI API mapping in next meeting. Today.
Sure. We can create a slide for the SAI, say how we mapping this structure to the SAI.
Yeah, I think that makes sense.
Okay. Any other comments? I think Donna, do you have any suggestion or something?
No, but frankly, you move too fast for me to keep up in the data structure changes.
Okay.
So
I will send out the deck. Maybe we can then next week we can go over this one more time. Like, but they probably go over more detail into the data structures and how we handle it. This today more like say give the everybody set the tune to say, hey, what we want to achieve, right? So we'll send out this deck, so maybe like everyone can take a look at this data structure change proposals. So then next week can go over this data structure change and as well as the SAI how we mapping the structure from through the PMSync to the Zebra to the SAI. Good.
Probably Eddie, I don't know, this peak table added only for the SRv6 at this point, right? I don't know if you want to realize that table for generic IPT prefix cases. I don't know what changes are expected there.
For the general IP, we don't need the PIX because PIX is a VPN context. So you need the VPN information, then you need content. You need that. That's why Mike said that this could be empty. So for the global table, we don't need this PIX.
Okay. Okay. Yeah, I will look at it. Sure. Thank you.
Yeah. So I will send out this, and then we probably next week let's continue on this topic. Okay.
Sounds good. Thanks, guys.
Okay. Thanks. Thanks everyone.
Thank you.
Bye.
Bye.
Mm.
Okay, bye.